Hello, so we have this diagram here and we have to solve 3 questions. So first we have to find the area of AOC, which is this triangle here. And since we know what the values A and B are and what C is, we can just plug in the formula we get from the data booklet. So that would be half r squared sine theta. Okay, now we have to find the area of AOB, and this is a right angle triangle this time. So we can use half of the height times the base. But so we know the height, now we have to know what the base is. Well, AB is equal to tan theta times r, and that's because tan theta is equal to opposite over adjacent, and the opposite is AB, and the adjacents r. So those two cancel out, so therefore AB is equal to tan theta times r. So that's one of our lengths. So for AOB, that would equal, well, first we have to do the half. Then we have the height, which is r. And now we have the base, which is tan theta times r. Okay. So now we have to show that sine theta is less than theta, which is less than tan theta, within the restrictions of theta being more than 0 but being less than pi over 2. Well, first let's so to find what the value of theta is in comparison of these two, we're going to need to actually find the sector here. And actually the sector is this formula right here. We don't even need to do anything. Sector AOC is equal to half r squared theta. Okay, so we can see here that that the area of triangle AOC, we can see that that's actually less than the segment here because of this little area here. So that's less than the area of sector AOC, and that is less than the area of AOB, triangle AOB. I'll put those in brackets so it's a little bit more clear. Okay, so now let's put down the expressions for all of them. So area of AOC, that's half r squared sine theta, which is less than half r squared theta, which is less than half r squared tan theta. Okay, now we can divide half of r squared on both sides. So then we get sine theta is less than theta, which is less than tan theta. And we know this triangle can only form if the angle is in between 0 and pi over 2, not inclusive. So therefore, here we go. This is how you prove the third one. Thank you.